Hello all and welcome to this video where we look at determining the rule for the graph of a polynomial. In particular we're going to be looking at cubics more so and a little bit of quartics. I apologise if I'm a little bit nasally or bumbling. I'm a bit sick at the moment, but we'll get this done. This is just an extension of when we were finding the equations or finding the rule of a quadratic. The same principles apply. We have various forms of the equation. We just need to be smart about which one we pick so that when we're substituting in points or given information, we can generate our equation nice and quick. So the 5 different forms that we will generally come across for a polynomial, especially cubic, are as follows. Form 1, which is what I call point of inflection, or that we're used to as the general form. But the point of inflection we know occurs at h and k, and then we would be able to figure out a from another point. So if we know we're told the cubic has a point of inflection, well, we know that point of inflection occurs at h, k. We can take that straight away into this general form and then sub in some other bit of data about it to figure out what a is. Second form, or let's jump to number 3 first. Number 3 is the intercept form. Okay, if we're given, if we have 3 different intercepts, so we might have something that looks like that. We have intercept 1, intercept 2, intercept 3. We can substitute those values in for E, F, and G, whatever they are. Just got to be careful that we have this negative sign in front of it, so we just got to be careful with our signs. So say if our first intercept was at -4, well, we put in, for E, we put in -4, and because it's subtracting the negative, that would actually eventually be written as x plus 4. But that's just like a quadratic. This time though, instead of 2 intercepts, we've got 3 intercepts. So that's our intercept form. Now we have a special version of the intercept form, which is number 2 here, where what happens if we have one of the intercepts repeated? That is, or one of the factors repeated, that is when we get a particular situation that may be like, why has my pen stopped working? Maybe PowerPoint's having a glitch. Yes, it works. Okay. We may have something like this, where our intercept, okay, is also a turning point, and when that's the case, that is the repeated root. So in this case, it's the x minus e all squared. So in this case, this may be occurring at 3. So we'd write this as x minus 3 all squared. And then our other intercept over here, this one here, would be our f. The key trick with this one is the intercept that's our turning point, this critical one here, that has to be the repeated root, the one that gets the square put on top of it. So there's that one. The fourth form is used when we're given 2 points and the graph passes through the origin. Because it's passing through the origin, we might have something like that. Since it's passing through the origin, that means its y-intercept is 0. So the y-intercept is equal to 0. That means our constant on the end, in this case for a cubic, is d. D is going to be 0. So if it's passing through the origin, the constant on the end is just 0, so that disappears. Now we can have ax cubed plus bx, or we could also have plus bx squared. Either of those ones. You're rarely given this situation unless you're actually told it's, oh, the graph of a cubic is of this form. So you instantly know it's going to be written like that. Or it might be the graph of the cubic is of the form of y equals ax cubed plus bx squared, and passes through the origin, or you give a picture of it. So this number 4 case is a bit more uncommon, but it does pop up. So it's just to be aware though, if it's passing through the origin, you instantly get the shortcut and say that, well, my plus D here, that D needs to be equal to 0. So it disappears. And finally, the fifth one, which is probably the most annoying, is used when you're given 4 random points on the curve. So you're given 4 bits of information there, may be turning points, but they may not be intercepts, they may be y-intercept, they may not be, but it's just generally not matching any of those other patterns. You just have to go with this regular polynomial form of the equation and then solve using simultaneous equations. Now, we have 4 unknowns here. We have alpha, Bravo, Charlie, Delta. We don't know those, so we're going to need 4 bits of data to be able to figure that out, so you end up with 4 equations to try and solve. That fifth one, you're never really going to have to do it by hand. And if you are having to do it by hand, you get the y-intercept straight away, so that gets us D really quickly. You're normally given, that goes through the point as 0, 3. Well, since x is 0, that must be our y-intercept, so straight away we get our D value. And then one of the others is pretty quick to find too, pretty straightforward, and then we're just left with a regular simultaneous equation. If you are given one that's not nice, it's going to be CAS active. So let's have a go at doing some of these. So a cubic has the rule of the form y equals ax minus 3 all cubed plus 1, and the point 4, 12 is on the graph of the function. Find the value of a. So we're told it's actually of this point of inflection form just by recognizing, since it's the factor repeated 3 times. And we could say the point of inflection needs to be at 3, 1. Just as an aside, so we're starting to recognize those patterns. But it goes through 4, 12, so we're going to sub in 4, 12. So we'll get 12 is equal to a 4 minus 3 all cubed plus 1. We get 12 is equal to a 1 cubed plus 1. So we get 12 is equal to a plus 1. So we get 11 is equal to a. So therefore, we can finish there because it just asks find the value of a. So you don't need to write out the full equation, but let's get in the habit of saying that, well, in this case, y is going to be equal to 11 minus x minus 3 all cubed plus 1. Part B, cubic function has the rule of form y equals a bracket x minus 2 bracket x plus 3 bracket x minus 1. And the point 3, 24 is on the graph of the function. Again, find the value a. So we don't need to write the final equation, we just need to figure out what a is. But what type of form is this quickly? We can recognize this is intercept form. Okay, and we have 3 factors. So straight away I could tell that this needs to go through, 2, needs to go through 1, and it also needs to go through -3. So the graph is going to look something like that. Straight away I can tell that, and now I just need to figure out what the a is. So we're going to sub in 3, 24. We get 24 is equal to a bracket 3 minus 2 bracket 3 plus 3 bracket 3 minus 1. We get 24 is equal to a 1, 6, 2. So we get 24 is equal to 12a. So a is equal to 24 on 12, which is equal to 2. Even though we don't need to write it, let's get in the habit. Y is equal to 2 bracket x minus 2, x plus 3, x minus 1. Lovely. Okay. Here's that one. We're told cubic function has the rule of the form y is equal to ax cubed plus bx. And the point 1, 16 and 2, 40 is on the graph of the function. Find the values of a and b. Okay, we have 2 unknowns. We have a and b, and we have 2 data points, so we can solve this. So let's substitute this in. So I'm going to sub in 1, 16, and I get 16 is equal to a by 1 cubed plus b by 1, so I get 16 is equal to a plus b. That's nice. I'm also going to sub in 2, 40. So I get 40 is equal to a by 2 cubed plus b by 2. So I get 40 is equal to 2 cubed is 8, a plus 2b. Okay, so I have two equations now. I have equation 1 here and I have equation 2. I could use elimination or substitution. If I was doing elimination, which I wouldn't actually suggest, this one's a quicker one probably to do substitution, but elimination, I would do equation 1 times by 2, which gives me 16 by 2 is 32 is equal to 2a plus 2b, and then I'd also take away then from that equation 2, which is 40 equals 8a plus 2b, and because we have the 2b and the 2b, they cancel, and we can go from there. But I can also rearrange this equation 1 to make it equal to a is equal to 16 take away b. Might just call that equation 3 for now. And I can substitute that straight into equation 2. I'm going to sub 3 into 2, and I get 40 is equal to 8 by 16 take away b plus 2b, so I get 40 is equal to 8 16 is, well, 8 10s are 80 plus 8 6s are 40. Oh, work brain. 42, so 80 plus 42 is 122. Take away 8b plus 2b. I get 40 is equal to 122. Take away 6b. Get 6b is equal to 122. Take away 40 is 82. So b is equal to 82 on 6, which is 60 is 10 plus another 2 gets me up to no plus. That's not nice. Let's start simplifying it. 82 can give me 41 on 3. Now I may have made an error somewhere here with my algebra, but we'll go with that. Yeah, we'll go with that. That the b's that fraction form. Well, up here, what do we get? We'll see. Over here we do this subtraction. We get negative 8 is equal to negative 6a. A is going to be 6, which is also a fraction. We'll keep going with our method, see what we get for a. So we've got b is equal to 41 on 3. I'm going to substitute that into equation 3. So I'm going to sub b is equal to 41 on 3 into equation 3. So I get a is equal to 16 take away 41 on 3, which a is equal to 16 by 3, 30, 48, 48 take away 41 on 3 gives me 7 on 3. Did I do that right? 16 by 3, 3 6s, in there, 3. Yes. Okay. Right. I'm getting something wrong here. That was 4 on 3. What have I done wrong? That's 16 by 8. Probably did this wrong. 8 6s. 6 6s are 36, 42, 48. I have made a mistake. 4, 128. It should have been 128. 128. 128 take away 40 is 80. Oh my god, I can't get my brain to work. My apologies. 88. So we get 88 on 6, which gives me 44 on 3. Which can't be simplified? No. 44 on 3, 44 on 3 gives me 4 on 3, which is what matched using our elimination up there for the A. Okay, there we go. So B is equal to 44 on 3, A is equal to 4 on 3. Just asked us to find the value of A and B, so we don't need to write out the equation. But apologize for the mistake, but hey, that's where it's handy to check your work. Next slide, right, using our CAS. So like I said, this is for the ones where you just given 5 random bits of information. Pardon me. 5 random bits of information. So in this case, it's find the values of A, B, C, and D in the cubic equation y equals the standard polynomial form, given that we have the points -1, 18, 0, -5, 1, -4, and 2, -9 lie on its graph. So the way you go about this is we first define the equation. Okay, so we want to define it, we want to store it, okay, which is what we've done up here. And I say here it is really good habit to put the multiply sign between the variables. So I actually haven't done it in this screenshot, but what it should look like is A times by x cubed plus B times by x squared plus C times by x, and then plus D. Because if you don't put the multiply sign in there, sometimes the CAS system interprets it as ax cubed, and it interprets this as just a named variable. Instead of just using a single letter, it thinks this is, and you can do this anytime, and it's done a lot in computer systems where your variable, you don't give it a single letter, you actually give it a full-length name. So it thinks this is just one single variable actually called ax, and it's going to cube the whole lot. And if you bring up your CAS, and if I actually drag this over here, I can show you a time when it does that. Okay, here we go. So in this one here, I defined it as ax all cubed, and I used the letter A and I also used the letter X from the keyboard. I used that X there instead of going AX, and you'll see these ones are bold and look a little bit different because I actually used the variable X, okay, in that case. So when I used it there, it was fine, but when I did AB, I used both the letter A and the letter X, and if I hit enter, come back up here, you can see in this bit here, it doesn't put the dot between the A and the X, it's reading that as a single variable. So it's a really good habit, especially if you're just using the keyboard and not using the actual variable board, that you put the time sign in between there, and that will avoid those issues. The other way you can avoid it on this type of calculator is that for the A, B, C, and D, you can use the alphabet keyboard, which is fine, and then use this X down here, the variable X above the 7, as your actual X. And that will also work onto the latest system. So that's a good thing to point out. And then what you do once you have that, okay, we've got our function defined, you need to then use your system of equation solver. So that is in Math 1, and it's that button there, and it gives us 2. It's the simultaneous solver, but if I press it again while in it, it turns into a 3 equation, press it again, turns it into a 4 equation. So you want to press that button and then press it more times if you have more data points, more variables to solve from, and then we enter our information into it. So we're told, well, X is -1, Y is equal to -18, so you can say f of -1 is equal to 18, and that's how you enter it using our defined function. Because we've already saved it, it allows us to enter like this rather than writing out 4 times 18 equals a -1 cubed plus b -1 squared plus c by -1 plus d. You could write that instead of that first line, but it's much easier to define the function first and then write this out in the shorthand function notation. And once you do that, then hit enter and it's going to give you your answer. So let's have a go. Find the values of a, b, c, and d in the cubic equation, blah, given that those points lie on it. So come back to the CAS. I'll do it on the CAS to show you. We want to define f of x is equal to ax to the 3 plus b, and you'll notice I'm using the x above the 7 as to get the proper variable x squared plus cx plus d there, and I should technically change that to that x there. That will work better, and if you want to check, you can just type f of x, see that it comes up. Cool, and that's worked, and it's put the dots in between. That means it is recognizing that the c and the x are different variables, the b and the x are different variables, so we've got that. We go back to Math 1, and we're up to 21 minutes, I apologize. But go through, and we want f of -4 is equal to -157, f of -2 is equal to -29, f of 0, and we could have recognized f of 0 is equal to -1, so straight away we know that's our d value, and then f of 2 is 23. And what are we solving for? Well, we actually want to figure out a, b, c, d are incorrect number of oh, that was terrible. No. Equals 23. There we go. There's our values. A is equal to 2, b is equal to -half, a is equal to 2, b is equal to -half, c is 5, and d is 1. D is equal to 5, and d is equal to -1, which matches that there. Cool. Last example 4, really quickly, the graph shown on the right is a cubic function. Find the rule of function. Straight away I can see it's an intercept and it's also a turning point repeated. So this needs to be of the form a, x minus e all squared, x minus f. E needs to be the repeated root, so we get y is equal to a x minus 2. We put the 2 in there, all squared. And then the other intercept is actually at 0, so we get x minus 0. So we get y is equal to a x minus 2 all squared by x, or we could write it as y equals ax x minus 2 all squared. And then substitute in the point 3, 6 to figure out what a is, but I'll let you do that yourself. And lastly, just want to note there's an error on question 6a on page 195. The graph should actually come down through the intercept at -0.5. That's it for the video. I apologize for the extra 4 minutes, but I hope that helps, and I hope this is reminding you of some of this stuff from quadratics. If you have any questions, put it in the comments below or put it on our Google Classroom.